This lesson describes the Electronic Flight Information System, or EFIS, and looks specifically at the Electronic Attitude Director Indicator, or EADI, which forms part of the Electronic Flight Information System. A companion lesson later looks at the Electronic Horizontal Situation Indicator, or EHSI. Some of the example displays that we show are Boeing systems, and others are Airbus. There are differences, so these displays are representative only. You will find that other manufacturers may present this information in slightly differing formats. The Electronic Flight Instrument System, or EFIS, presents attitude and navigation information on two electronic display units: the Attitude Director Indicator, or EADI, and the Horizontal Situation Indicator, or EHSI. The system interacts with the flight management system and utilizes color cathode ray tube or liquid crystal displays. It is comparatively advanced, not only in terms of construction, but also in terms of the attitude and navigational data which can be presented. However, as with all technology, new developments are being continuously evolved. A complete EFIS installation is made up of two individual systems, one for the captain and one for the first officer. In the diagrammatic layout here, we can see that each system contains an EADI, which is the preferred Boeing term. Airbus call it a Primary Flight Display, or PFD. There is also an EHSI, as Boeing call it. Airbus call it a Navigation Display, or ND. However, you should be prepared to see EADI and PFD used interchangeably, and the same with EHSI and ND. Also, other manufacturers may use either term. Additionally, there is a control panel, a symbol generator, and a remote light sensor unit, which responds to ambient light conditions on the flight deck to automatically adjust the brightness of the screen display. In addition, a third backup symbol generator is incorporated, in case a system symbol generator should fail. In this lesson, we are going to look only at the Electronic Attitude Director, or EADI part of the EFIS system. The EADI is an electronic representation of an Attitude Director Indicator. Here is the traditional gull wing motif of the attitude indicator in a slightly modified form, overlaid on the horizon background. The EADI therefore displays normal pitch and roll attitude indications. However, Flight Director command bars can also be superimposed. These can be represented in two basic forms, either the V-wedge type or the crossbar type. Command bars are looked at in more detail in the lessons on automatic flight and control systems. At this stage, note that the example EADI shown here incorporates electronically generated cross-command bars, the aim being to keep the crossbars centered on the aircraft symbol. Localizer and glide slope deviation indicators are also incorporated. Other key information can also be shown, and we will work our way around the EADI display in a clockwise direction. So, starting at the lower left-hand corner, we can see the active navigation aid in use, and an airspeed tape which shows indicated airspeed or calibrated airspeed from the air data computer. Critical speeds and an airspeed trend are overlaid on the airspeed tape. The airspeed trend pointer indicates the direction of the difference between actual speed and commanded speed on the speed error scale. Moving to the top of the screen display, we can see in green the auto flight mode selected. The speed symbol shows the auto throttle status. This displays whether takeoff and go-around power, which is TOGA for short, maximum takeoff power, climb power or thrust speed modes have been selected. The next column shows the pitch mode selected for vertical nav or glide slope, and the third, the heading, nav or localizer mode engaged. The autopilot status is shown to the right. In the example shown here, we can see that autopilots 1 and 2 are engaged, along with the autothrottle. On the right-hand side of the display, we can see that there is an altimeter tape and a vertical speed indicator. At the base of the display, we can see there is a heading tape and a heading bug. In this particular display, which is representative of the primary flight display on an Airbus A300, radio altitude is incorporated in the location shown here. Note, however, that the layout of screen displays can vary slightly between manufacturers, although the information displayed will be essentially the same. Often the radio altitude display, which also incorporates a decision height alert, is located at the bottom right of the screen. The equivalent Boeing system is similar, but a lot less cluttered. There is no need to learn the detail of these displays. The idea is simply to show you the type of information displayed. As we said earlier, details will vary from system to system. Let's look now at the colours generally used in EFIS. White denotes present status information. Green is also used for present status information, where contrast with white symbols is required, or for data with a lower priority than white. Magenta is used for command information, pointers, symbols, and fly-to conditions. Cyan is used for non-active and background information. Red denotes warning information. And amber is used for cautionary information, faults and flags. EADI control is incorporated in the EFIS control panel. Both captain and first officer have their own EFIS control panel, each controlling the displays of their respective EADI and EHSI units. We can see a Boeing system illustrated here. This is the EADI or ADI section of the control panel. The controls are straightforward, the BRT control being simply a brightness control, which can be used to manually adjust the brightness of the EADI display. DH cell is the decision height selector. It is a rotary switch and is used to select the appropriate decision height alert. DHRST is the decision height reset button. It cancels the decision height indication on the radio altimeter display when pressed. DHREF is the decision height reference indicator, and this displays the selected decision height on the EADI as well as on the control unit. Radio altitude is displayed on the screen below 2,500 feet. As mentioned earlier, it may be presented in differing formats. A common format is illustrated here. Between 2,500 feet and 1,000 feet above ground level, the radio altitude is digitally displayed. Below 1,000 feet, the digital readout continues, but the display changes to incorporate a circular white arc, which is graduated in 100-foot increments. The length of the arc reduces in an anti-clockwise direction as height above ground level reduces. The selected decision height is displayed by a magenta-coloured marker on the circular white arc. At decision height plus 100 feet, an oral alert chime sounds. At decision height, the magenta marker and white arc will flash and change to yellow, and the alert tone ceases. Pressing the DHRST button will cancel the alert chime and the marker flashing, and will also change the decision height displays back to their normal colour. Finally, let's look at EADI failure annunciations. Should a signal from a data source fail, the failed data source will be highlighted or flagged in yellow. Here we can see failure annunciations of the radio altimeter, the glide slope signal, the localizer, and the speed computer. A complete EFIS installation is made up of two individual systems. Each system comprises an electronic attitude director indicator, or EADI, an electronic horizontal situation indicator, or EHSI, a control panel, a symbol generator, and a remote light sensor unit. There is also a third backup symbol generator. The EADI is an electronic representation of an artificial horizon or attitude indicator. There is a color coding convention. Incorporated in the EADI display are flight director command bars, localizer and glide slope deviation indicators, active navigation aids, calibrated airspeed and critical speeds, airspeed trend, autoflight modes, autopilot status, altimeter and vertical speed indicator, aircraft heading, and radio altitude. Radio altitude is displayed below 2,500 feet above ground level. On the EADI control panel, the BRT knob controls the screen brightness. DH-Cell is the decision height selector. DH-RST is the decision height reset button. DH-Ref is the decision height reference indicator. In the event of an input failure, there is a warning flag display system.